Hey everyone, it's Miss O'Neill here, and today is a good day to have a good day. We are back at it again with science. Today we are on lesson number 30. We're going to be observing and describing the effect of friction. So observing is a big word that means taking a look at, and describing is another big word that means talking about. Okay, so we are looking at and talking about the effect of friction. Friction is our big word of the day. So the last time we had a science lesson, we learned about an invisible force that pulls things towards the earth. What was that force called? Nice, that was gravity. And remember, a force is any push or pull on an object. Today we're talking about the force called friction. Be my echo. Friction. Friction. Wonderful. So friction is, be my echo again, an invisible force that can slow or stop a moving object. Wonderful. One more time together. An invisible force that can slow or stop a moving object. Wonderful. So let's go ahead and explore what friction really is. So right here in front of me, I have a lot of things, but right now we're going to be talking about this. This is the top of just like an empty binder. How would you describe the texture, what it feels like on your hand when you run your fingers across a binder? Give me some adjectives. Give me some describing words here. I'm gonna go with smooth. It feels kind of plasticky. It does not feel rough and it does not feel bumpy. I could move my hand across it really, really easily. Now I'm gonna put some salt on here. A bunch of salt in a bowl. I'm just going to sprinkle, sprinkle, sprinkle. Wonderful. Can you see that? Yeah, awesome. Cool beans. So now if I run my hand across the binder, it's gonna feel not so smooth. It's gonna feel rough. It might feel a little bit gritty. What other describing words, what other adjectives do you have to talk about the texture here? Maybe bumpy. Almost a little bit like sandpaper. Yeah, the salt makes it a lot harder for me to take my fingers and run it across the binder. The salt is creating friction here. So let's go ahead and do another little experiment here. Yes, okay, awesome. So I'm gonna really carefully just put this binder over my little salt bowl. I'm gonna try to get all of the salt back in the bowl. Awesome. Oh, that went a lot better than I thought it was gonna. Awesome. So I'm gonna move the camera down just a little bit. So just bear with me here, because now it's experiment time again. Awesome. So I have it at a little bit of an incline because it is a binder. So the incline just means it's up kind of like on a hill almost. So if I put a crayon up at the top of here, my crayon would just roll right down. And I also have a towel here, just like a regular kitchen towel. I'm going to lay it out and I'm going to put it like here. Kind of tuck that in so it's a little easier to see. Wonderful. Cool. It's tie-dye too. I really, really like this towel. So I have two crayons here that are the exact same size. They are not the same color. One is purple, one is green. But they're the same size and they're the same shape. All right, which surface do you think has a rougher texture here. A little rough, a little bumpy. Is it going to be the binder cover or is it going to be the towel? Yeah, you're right. It's going to be the towel. So for our experiment, we're just going to see what happens when I take these two crayons that are the exact same size and same shape. I'm going to put one of them on the towel and I'm going to put one of them on the binder. Which crayon do you think will roll off the easiest? Do you think it'll be the crayon right on the binder cover, or do you think it's going to be the crayon on the towel? Which crayon is going to roll off of here the easiest? A lot of you might be thinking the binder cover, so let's go ahead and see. Yeah, if you guess the binder cover, you are 100% right. So why? Why do you think that happened? Well, it happened because this surface is a lot smoother than the one with the towel on it. And the force of gravity, that invisible force, pulls the crayons towards the ground, but the force of friction will slow or stop them, okay? So the rougher surface of the towel slowed down the crayon. There was more friction between the crayon and the towel than the crayon and the smooth binder cover. All right. Yes, wonderful. Cool. We're moving on to talking a little bit more about friction. I'm going to move you, whoops, up. I hope. Maybe. I'm a teacher, not a cameraman. Tilting a little bit. Hold on. Bear with me. A little bit more. Get it even. Wonderful. Close enough. Cool beans. So air and water can also create friction. Haha. Air and water can also create friction and affect how objects move. They can either slow or stop. I want you to think about running. If you're running like outside, is it easier to run outside on a blacktop or on the sidewalk? Or is it easier to run in a pool? Have you ever tried to run in a pool before? Maybe even walk? Yeah, the water creates friction and it slows you down. It's so much easier to walk when you're just on the ground instead of in water. Air friction can also slow down objects. So what happened in our gravity experiment in our last science lesson? We dropped two objects from the same height and they hit the ground at the same time. One of them was a crumpled up piece of paper and then the other one was a pen. Do you remember what that experiment was called? It starts with a G. Nice, Galileo's experiment. So when we drop a flat sheet of paper, just a regular piece of paper, and it's flat, and I'm going to drop it, the air friction will cause the paper to float in the air a little bit and fall a lot more slowly. You see how it kind of, yeah, it falls a lot more slowly than if I took it and crumpled it up and just dropped it. That went by a lot faster than when I had the flat piece of paper. And that's because of air friction that slowed it down. Okay? Wonderful. So I'm going to read a little bit about friction, not fiction. Oh my gosh. I'm really excited to talk about foundations today, I guess. Awesome. I'm going to read to you a little bit about friction now, okay? Friction is an invisible force that can slow or stop a moving object. Remember that the word invisible means cannot be seen. The friction between two objects depends on the surfaces of the objects. Rougher textured objects will have more friction than smoother objects. If we push with the same force, a toy car will move farther across a tile or wood floor than a carpeted floor. This is because carpet has a rougher surface than wood or tile. That's a really easy experiment that you could do inside of your own houses, right? If you have like a toy car laying around, you can even, did what I did, you can use crayons if you really, really wanted to. Try your best to use the same force and see what will happen. Will your object move faster across wood or tile, or will it move faster across the carpet? If we're following the laws of friction, it'll move faster across the wood or the tile. All right. Cool. Sometimes it is important to have more friction. Shoes with rough soles or bottoms help us avoid slipping when we play games outside or in the gym. If you take your sneaker and you look at the bottom of it, let me grab my marker really quick. Here is the bottom of a shoe. Sometimes you might find cool designs on the bottom of a shoe that look kind of squiggly. That's to help create more friction. So if you're running on like a wet floor, let's say, that you absolutely shouldn't do anyway, but just in case if you were, the rough soles would create more friction and they would help slow you down a little bit, okay? Awesome. Wonderful. That's it for science today. I hope you enjoyed our lesson on friction. Yeah, that's it from me. I love you lots. I miss you a bunch, and I will see you later. Bye.